not just particles.
Super slash.
That's right, where you start. Now, if the tail of a displacement vector is where you start, what do you think the tip will represent?
Where you end.
Where you end, where you wind up. Now remember the difference between displacement and distance. Will the displacement vector necessarily have any relationship to how you got there? No. If I run around this room 10 times from here, and I wind up here, then my displacement vector would only be one tile long to my left, even though I ran around the room 10 times to get here. My distance vectors, they would probably be a lot of different vectors. Yes, sir?
Can vectors curve?
No. What we usually use vectors for, but vectors can represent curved motion.
Is it like
We'll
those
talk
things,
this much about that
is
today.
it like those things where you can make the circle using only straight lines?
Yeah. Yes, very much like that. Yeah. Vectors don't curve, but what they're talking about often does. Okay? And that also gets to the difference, Parker, between average and instantaneous velocities. Remember we talked about that? As long as I don't say your last name, it's okay. Did I call you? I hope I didn't call you by your full name. I'm not sure if I should say that anagram of your name I often call you by either. Someone might figure that out. First name's pretty safe.
But we all go to this school. Everyone knows who it is.
I know, but my fans in other parts of the world don't need to know your
Yeah, because
names.
someone from Australia is going to come
Looking for you. That's
at
right.
this one school.
Exactly.
I'm searching for...
Yes, thank you. Now, the displacement vector notation. Your book always calls the displacement vector a stylized lowercase r with an arrow on top and a triangle in front. Who knows what the triangle means?
Ooh, wait, what's that?
Change. Delta. Change.
Delta for change. This is delta r
You're both right.
vector. So the triangle is the lowercase Greek letter delta.
That's displacement.
And this is your displacement vector. And sometimes it's also written as your final vector, vector r sub f, minus your initial vector. Not sure how much we'll do with that yet. That's another way some people write your displacement vector. Okay? Now, your velocity vector, if you've really been paying attention about multiplying vectors and scalars and about triangles, this will go very quickly. If you haven't been, I may still go quickly. But I'll try not to. I'll try and go clearly. Velocity.
Is that final minus initial?
Yes. R sub f minus R sub initial. Okay, velocity. I'm going to sit down for velocity for a moment. No, I'm not.
I'm on a horse.
Now I'm on a horse. Here are those tickets to that thing you love.
Now they're dying.
Your velocity, your average velocity vector, okay, is going to be your displacement vector divided by how much time has changed in the time we're talking about. Now,
AVE or AVG?
AVE. AVE for average. That's how I'm using it. Your displacement vector is a vector. Does it look like I'm writing time as a vector?
Nine.
No, it looks like I'm writing time as a number, or a scalar. So time is a scalar, r is a vector. Another way I can write division is multiplying by a reciprocal. So I can write this, left out my triangle, as a scalar times a vector. Okay, yesterday in the homework we talked about this, and in a couple of problems. Multiplying a vector times a scalar, does that change the vector's magnitude?
No, it just makes it bigger or smaller.
Well, that is the magnitude.
Oh.
So it does. So does it change the vector's magnitude?
Yeah.
Yes, that was perfect. Thank you. I couldn't have defined it better. Okay, does it change the vector's direction?
No.
No, it does not change the vector's direction.
No, it just changes.
I know, it's right. No, it just makes it bigger or smaller. Yes, go ahead real quick. Okay, so that changes. So, does velocity have to be in the same direction as displacement? If you're multiplying a vector by a scalar, are you changing its direction?
Nine.
No, you're just making it bigger or smaller. Okay.
Which is the magnitude.
Which is the magnitude. Sasha will never forget that now.
I probably will.
So, if I am going...
Sasha's real name is...
Stop. So, if I am walking this way, my displacement is this way, right? Does my velocity also have to be this way?
No.
It.
Yes.
Yeah, it does. Velocity does. Velocity has to be in the direction of displacement.
I disagree heavily.
Yeah? How come?
If you're going backwards,
He's doing it for the sake
all
of
the way around,
disagreeing.
end up there, your displacement is the same, but your velocity went backwards.
So your directions changed.
That would be for the displacement. Well, you see, that gets back to the displacement versus distance thing.
You said displacement, not distance.
Yes, but we're talking about velocity average, which only deals with displacement.
But couldn't you just say you're going backwards all the way to there, which will take you to the same place, yet you still have
You're
to
just
take-
arguing for the sake of arguing.
Yeah, you really are.
No, I'm
No.
actually...
Well, okay, see, the
I'm
thing is,
confused.
well, hang on a sec. If we just look at displacement, okay, and I walk backwards all the way from there to there, whether I walk backwards or forwards doesn't matter anymore, because backwards and forwards was what I said to just describe one-dimensional motion.
But then your velocity, then your displacement is not the same place as your final displacement, which goes against what you just said. That's what I'm saying.
No, it doesn't, because if we talk about displacement, final displacement, if I walk backwards in a circle and I wind up there, okay, in general, this has been our positive x-axis motion, right? Then even if I walked backwards, I'm going to have a positive displacement.
But wouldn't you have a negative...
No, my average velocity is just going to be how long it took me, is going to be how far I went in that direction divided by how long it took me. So what I'm going to have is a positive velocity in that direction, even if I ran backwards in a giant circle to get there. So if we just look at displacement, I'm only going to have a positive velocity in that direction and a positive displacement in that direction. As long as we keep saying the word displacement and we keep saying that's positive, it does not matter how I got there. But if I take away v sub average, when we get to calculus, though, and you start carefully defining the difference between average and instantaneous velocity, then we can have like an hour-long conversation about what you just said. But right now, we're just talking about displacement. So, in general, but now, well, let's go in your direction. Let's talk more about what you brought up, though. But let's not have me walk backwards in a circle, because that gets confusing. Okay? Let's just talk a little about instantaneous velocity. I am now walking towards this point, not running there backwards. I'm just walking towards this point. At this instant, I am changing my displacement in this positive direction, right? Then at this
We're still
instant,
talking about vectors.
yeah. Then at this instant, my velocity has to be a positive vector in the same direction. Okay? Parker, to go back to your example, if I'm running backwards around the room, so at some point I'm going like this, at this point, at this instant, I'm moving in this direction, right? And at this instant, my velocity is also moving in this direction. So you just have to be very careful. There's a good case for what you were just talking about. You need to continue through to vector calculus, also called multivariable calculus. Second year of college, third calculus
You're
course.
on
I have
tangent.
to.
Well, that's the point where you and I can sit down and really have this conversation.
You're on a tangent.
I am so on a tangent. Tangent. Excellent. Good point. Hold that word. We're going to get back to that. Now,
It didn't.
however, let's go back to just my simple one-dimensional example again. Okay, before I